Good morning, guys. Let's continue. I hope you guys are able to see my screen.
Yes.
Yeah, thank you. So let's quickly look at what we have learned yesterday. Yeah, yesterday we looked at the linked list. And in the linked list, basically we looked at stack implementation using linked list. So that means we have to implement the pop method, peek method, push method. So we implemented all of this. And I see that Shiva has responded with the answer. Thanks, Shiva. Thanks for trying. So does anyone has any questions on this? How to implement a stack using linked list? Any questions or anyone tried apart from Shiva? Did anyone try writing the code?
Yes, sir.
Yeah. Were you have any issues?
No, sir.
Okay. You're able to write without looking at the code that I have given, right?
Yes, sir.
Yeah. Thanks. Yeah. So if you have any questions, guys, please ask me. Now, today we are going to look at the topic called queue. Okay. Now, if you look at the notes that I have given in the starting, the queue is an interface that is also extending from collection interface, correct? Let me show you the guys. Is anyone going through the notes, guys? Anyone looked at the notes at least once?
Yeah.
You're able to understand the notes, right?
Yes.
So whatever I'm speaking in the class, I have just written that in the simple English words. Okay. So now if you look at the diagram that here, so the map is not a collection framework, right? But if you look at the collection from the collection list set and queue is getting this one. If you look at all this pink color or whatever this one, this color is a interface. So queue is an interface in Java and it is extended from another interface called collection. Okay. Now if you look at here, the blue color is it interface. See collection, from collection list queue set. So queue is an interface. Now what is a queue? Now we just have seen stack. What is the pattern that the stack will follow? What's that? Last in, first out, correct? Stack. I'm talking about a stack.
Yes.
Yeah. Now what does the queue will follow? First in, first out. So that means any data structure which is following the queue, I mean like first in, first out behavior, can I call it as a queue? So that means, yeah. So now can I say I can implement a queue using multiple ways? One way I can create a data structure. Internally, I can store the data in the form of array or in the form of node also. That means, can I say that again, I can implement the queue using an array, queue using a linked list, correct?
Yes.
Yeah. Now, what is exactly meant by first in, first out? So last in, first out, what is the example that I have told? Whenever I'm discussing the stack, whenever I say last in, first out, I have taken one example. What is that?
Plate examples.
So whenever we are washing the plates, we'll keep that one, right? Similarly, now for the queue follows first in, first out behavior. Okay. Queue is an interface in Java. Okay. Is the stack what? Is it an interface or class?
Stack is a class.
Stack is a class. And it is extending from? Vector. Okay. And is the stack synchronized?
Yes.
Yes. Because vector is synchronized, right? Yeah.
Yes.
Now queue is an interface and it follows first in, first out. If you go for a movie theater, and like nowadays we are buying the tickets in a Book My Show. But even if some people who are not buying the Book My Show tickets, you will go to the theater and you will stand in the queue for tickets. Am I right? So whenever you are standing in the queue, what is the fashion you will follow? Is the last person who is standing will be getting a ticket first, or first person who is standing will get a ticket first?
First one. First person.
And whenever you go for a temple, they'll provide, they'll give prasad, right? So whenever you want to take a prasad, what is that? Can you say that is also first in, first out?
Yes.
And if you want to get into a bus or train, whatever it is, in front of the bus or in side to the door, they have they will be writing, please maintain queue, correct? So that means a queue is nothing but if you are standing in first, you will be getting the opportunity first, right? So that's a queue behavior. Now, any data structure which is providing you this first inserted element is taken out first, then that is called as a queue. Okay. Now, in order to implement a queue, is it only, can I implement a queue only with an array?
No.
We can implement in any ways, right? Whatever, see, there are different ways to store the data. One is till now, you know, one is array and another is linked list. In future, you will get to know tree, right? So that means I can implement a queue using an array, queue using a, like as long as it is following the first in, first out, it doesn't matter how you are storing the data. So that's a queue behavior, right? So now, for example, let us take, this is a, first I am talking about an array implementation. Internally, I am using an array, okay? If I say 10, 20, 30, 40, 50, 60, okay? Now, so Q, now if I say, what is the first inserted element in this one? Can you please be little loud?
10.
10. So now that means if I have to delete the data, then which element I should delete?
10.
First in, first out means 10 only should come.
10 only.
Generally, if I use a remove method, I can delete anything. But if I have to say that this is an array and it is following the queue behavior, that means first in, first out. Correct? What is the first inserted element? 10. If I am deleting, the 10 should come out. So in the stack, what methods we have? Pop, peek, push. Correct? So pop method will delete last element and returns. Correct?
Yes.
Peek will just return last element and it will not return. Push means it will add element at last. Okay, done. Now, similarly, in the queue, we have some methods called poll, peek. Same method is also available in the queue also, peek. And then we can use a push method or add method or anything like push or add. So add or push is same like this. Now, whenever I say peek, in the stack, what does the peek method will do? It will return the top of the stack. When I say top of the stack means last element. Similarly, in the queue, the peek will return the head of the queue. What is the head? Head is nothing but the first inserted element. First inserted element is, if it is an array, then 0th index. If it is a linked list, what is the first inserted element, guys?
First node.
What is that? What is that first node is called as?
Head.
Head element, correct?
Yes.
Yeah. So that means the peek method will return the first inserted element and it will not delete. Now, what does the poll method will do? See here in the stack, whenever I say pop, what does it mean? Which element I am removing?
Top element of the stack.
Well,
So if I have to represent that in terms of remove method, how can I do? Remove what I should pass?
index.
Length -1.
Yeah, a dot length -1. That means removing the last element present in array is nothing but a pop method.
Yes.
Does everyone agrees with me? Removing the last element in the array is nothing but a pop method. Am I right?
Yes, yes.
Yes.
Yeah. Similarly, here, whenever you are doing the poll, what is the first in, first out? That means you are deleting the first element. Now, can I say call, what is the poll method? Can I say remove followed by 0, correct? Removing the first element is called as a poll method. Now, if I delete this element, you tell me, if I want to delete this element, what should I do, guys? What happens in the array list whenever you delete a 0th element or first element, something like that?
Right shift.
You have to, is it a right shift or left shift? You are taking this element, which
Left
direction
shift.
you are going? Left direction,
Left.
correct?
Yes.
Yeah. So here, so can I say left shift operation will happen?
Yes.
That means which one, which method you will be using? First, what are you doing? You have to find number of shift operations, correct?
Yes.
So now here, what is the formula for number of shift operations? A dot length minus index to be deleted minus 1. A dot length is in this scenario 6. Which index you are deleting using a poll method?
0th index.
0.
0 minus 1. How many iterations? 5,
Five.
correct?
5.
Now that, and if it is greater than 0, which method you will be using? System dot array copy, correct?
Yes.
And then you are passing all this, right? So I'm just talking about the implementation. We will write the code, but see, when in the stack we have some methods called pop method, peek method, push method. In the queue we have a method called poll. We have a method called peek. What does the poll method will do? It will remove the element head of the queue. It will return the head of the queue and it will remove. What is the meaning of head of the queue? Which is nothing but first inserted element. What is the peek method will do? It will return the head of the element. That is nothing but first inserted element. If it's an array, it's a 0th index. If it's a linked list, it's a head element. So now it's all and good. See, stack is a class and we can see the methods called peek method, pop method and all, right? But what is a queue? Queue is an interface. Can I create an object of queue directly and then call these methods?
No, implementation class.
There should be some implementation classes, correct? Let us see first queue. Now, can someone tell me, do we get a concurrent modification exception in stack?
No.
Will I be getting this concurrent modification exception in stack?
No, because those are
No.
not synchronized.
So is it synchronized means concurrent? We don't get a concurrent modification exception.
No, it's not.
What is it? So whenever I was explaining the concurrent modification exception, so whenever you are iterating over array, doing some structural modification, the concurrent modification exception is thrown. Internally, how it is identifying?
Based on
There is one variable.
mod for mod count.
Yeah, there is one variable called mod count, correct? So does it anything to do with the synchronized keyword?
No.
No, correct. So that means in vector, do you get a concurrent modification exception?
No.
In vector, we get it, right? So we have tried with an array list. See, if I want to know whether it is giving a concurrent modification exception or not, in the vector, I can go to the code, correct? Now, next method. In the next method, check for co-modification. See, mod count is not equal to expected mod count. Are they throwing?
Yes.
Yes.
So that means if they are using a mod count, then there is a possibility of returning a concurrent modification exception, right?
Yes.
So we get a concurrent modification exception in array list. In vector also we'll get it, correct?
Yes.
And do we get a concurrent modification exception in hash map?
Yes.
And do we get a concurrent modification exception in hash set?
Yes.
So to overcome the concurrent modification exception in hash set, what is the collection we should use?
Collection.
Copy on erase set.
Copy and write array set, correct?
Yes.
Yeah. To overcome in a array list, what we can use?
Copy and write set.
Copy on write array list.
Right.
Yeah. In hash map,
Copy and hash map.
see, you can copy, but it is not like that, right? There is a concurrent hash map, right? Do you know that concurrent hash map is there?
Yes.
Yeah, then see, you can copy that everything, but copy and write array list, copy and write array set is there, but you don't have a class called copy and write array map. In order to overcome the concurrent modification exception, we have a concurrent hash map. That is the most frequently asked question, right? What is a concurrent hash map? Why do you go for it, right? If you look at my notes, I have provided that information, guys. So that's the reason I'm asking you to look at the notes. Look at here. Look at here. So in a set, we go for a array set, copy and write array list. Separately, I have written. So just look at the notes once, okay? So in array list, to get rid of the concurrent modification exception, we go for copy on array, write array list. In a set, we go for copy and write array set. In a map, we go for concurrent hash map. Okay. Now, so now can I get a concurrent modification exception in a vector?
Yes.
Now that means can I get a concurrent modification exception in stack?
Yes.
Because vector
It
is
will take-
extending from stack, correct?
Correct.
Yeah. Now coming to the queue is an interface, right? Let us see what are the methods do we have. See, queue is an interface. Do you see queue is extending from collection? That means in collections, whatever the abstract methods are there, those already automatically will be copied to the queue.
Yes.
Yeah. And apart from that, it also has, look at here. See, we just discussed about poll method, peak method. There is one method called offer. Okay. Now, don't worry about this offer. I'll come to that later. If you look at the poll method, see, retrieves and removes the head of this queue or returns null if the queue is empty. So now, if the stack is empty, and if I'm trying to perform peak method and pop method, what happens?
Exception, stack modification exception.
Like empty stack exception will be thrown, right?
Yes.
So, but if I perform poll method on an empty queue, what happens? You can
Null.
see here, it returns null. Why it will return null? Or in the stack, whenever you are performing, whenever you're calling the pop method, what is happening? Can I say I'm reducing the size? See, for example, there are three elements, 10, 20, 30. Now, what is the size of array now?
3.
3. What is the size of a stack? 3. Now, if I call pop method once, what happens? It will return 30 and it will remove it, correct? And my size will become 2. Agree?
Yes.
Now, if I call pop again, what is the output?
20.
And what is the size after calling the pop?
1.
And if I call the pop method again,
10.
10.
and what is the size will become?
0.
That means every time you're calling the pop method, can I say you are reducing the size by -1?
Yes. Yes.
Now, if I allow the pop method again now, what my index will become? -1. But can you have an index -1 in array?
No.
Hence, the pop method is not allowed. Or whenever if you are performing the pop method or peak method on an empty stack, it will throw empty stack exception, correct?
Yes.
Yeah. Now, what happens in a queue? If the queue is empty, will it throw the exception or not? Let us see. Now, if I am removing the element, if I am removing the 0th element, what am I doing? Am I going in a negative index or not? If you look at any point of time, if I am removing the first element, second element, if it is present, it is coming into the first position, correct? So, but I am not going beyond 0. Am I right?
Yeah.
So whenever I'm deleting this element, what is happening? If there is a other element, then left shift operation is happening. But is there a way that I can go beyond 0? I mean, in a negative?
No, we can't.
No, correct? So that is the reason if your queue is empty, you don't, so you just created a queue and you did not added any data. If you create a queue, empty queue, and you perform the poll method, what is the output? You will get null, but you don't get an exception. Why you don't get an exception? Because in the queue, we are doing the left shift operation at any point of time. Your index will never go negative, correct? So that's the reason. Okay. So now if you look at here, there are some methods as we discussed. Poll method will return the head of the queue. Head of the queue is nothing but 0th element or head element. Similarly, peak method retrieves but does not remove. Okay. So is there any confusion between the stack peak method and queue peak method?
No.
Okay. Now let us see, since it is an interface, what are the classes that are implementing this queue interface? There are many classes. Now, there is one class called priority queue. Array blocking queue. Linked blocking queue. synchronous queue. There are many things. Okay. So the most important thing is you need to know priority queue. And apart from that, we also have some class called array DQ. Now, if you look at here, priority queue is there, but in the array blocking queue, what it is telling, it is a blocking queue. So in the queue data structure, first we have a queue. And before that, after that, we have a blocking queue. And also we have another interface we have called DQ. Okay. Now we are going to see what is a blocking queue, what is a DQ, what is a queue, what is a priority queue, everything. Okay. Now for time being, first let us try the queue examples and then see. The most frequently asked question is what is a priority queue? So priority queue follows the natural sorting order. com.ashok.it.queue. Let me create a class. Okay, now let's create main method. Okay, now here there is one class called linked blocking queue. Let me show you. Linked blocking queue. So do you guys see this linked blocking queue is a class?
Yes, correct.
Yes, and is it implementing what? Blocking
Yeah,
queue.
thank you.
You are not aware what is a blocking queue as of now, don't worry. But let's go here. Is a blocking queue is an interface?
Yes.
And it is extending from queue?
Yeah.
That means can I say that linked blocking queue is a class, directly or indirectly it is implementing queue interface, correct?
Yes.
Now if I want to use a queue, directly I cannot create an object for a queue interface, but can I create an object of linked blocking queue and use it?
Yes, we can.
Yeah. So that means one of the implementation of a queue is linked blocking queue. But you do not know what is a blocking queue and all, don't worry. Let's see first queue behavior and then we'll go into that. Integer L equal to new linked blocking queue. Okay, now L dot add 10. Let me add 05, 50, 05, 03, 02, 100. Sys out L. If I run the program, what is the output? Can someone tell me? It will give you the data, correct? That means, can I say it is giving you the insertion order?
Yes, it's giving me
It is
such-
not doing any sorting, correct? It is just giving the insertion order. Okay. Now, if I say sys out L dot poll, see, you have a method called poll. Now, after that, let me print it. L. Now, if you guys tell me, whenever I say poll method will see retrieves and removes the head of the queue or returns null if the queue is empty. Now, what is the first element? Head of the queue means the first element. In this array, what is the first element that I added?
10.
10. So now, if I run the program, 10 will be removed. Look at here. See, 10 is removed and then 50 has come into the 0th position, correct?
Yes.
And 5 is coming into the 0. So can I say that
Okay.
left shift is happening? Yes or no? Now, if I do it again, if I run this program again multiple times, every time it will delete the element, correct? See? So whenever I say poll, see here 50 is the first element, it is deleted. And then 5 has come into the 0th position. Then 5 is deleted. Then 3. Then 2 is deleted. Now 100. Now if I call the method again, 100 will be deleted and then queue will become empty. Now on top of empty queue, if I call the poll method, what it will return? Null. It will not return exception. Look at here, it is returning null, right? Now similarly, now let us call the peak method. Sys out L dot peak. Now if I call the peak method, what does the peak method will do? It will just return the top of the queue, but will it delete? No.
No.
Yeah. So this is that. So that means in a stack, can I say in the stack from where I am coming? from the length minus 1. Am I right?
Yes.
So whenever I do the pop method or peak method, I'm coming from the last in the stack. In the queue, from where I'm starting?
Head.
From the first, correct? When I
Yes.
say head or 0th position means, so that means, can I say, so if I take, this is my array. See, this is array, data structure is an array. I'm storing the data. See, this is just an array, I stored the data. Now, when can I call this as a stack? When can I call this as a stack?
Last in, first out.
That means in order to implement last in first out, from where should I start deleting the elements?
From the top.
Length minus 1. I mean,
So that
top
means,
of,
can I say from this end, correct? Can I, if I
Correct.
say this is a starting position, this is the ending position, correct? Okay. Now, if I start deleting the data or from this end, can I call it as a stack?
yes.
Now, how can I call this data structure as a queue?
Starting 0th position.
If I'm
If-
deleting the data from the 0th position, then can I call it as a queue?
Yes.
Yeah. Now here, in order to delete the data, you have a pop method, correct? Here you have a poll method. Okay. But what is the common method? Peak method. Here you have peak method. Here you have. In the peak, in the class stack class, you have a peak method. What it will return? Last element, like on top of the stack, and it will not delete. What does the peak method will do here? It will return the head of the queue, but it will not delete, correct?
Yes.
Now, see, for example, you now in your project or somewhere, you got a behavior. Sometimes you want to delete the data from the starting. Sometimes you want to delete the data from ending. Then can I say I have to club both?
Yes.
So that is nothing but a DQ. We have another interface called, see, we have seen the queue behavior, poll method, peak method, etc. Now I'm trying to tell you what is a DQ. So there is another interface called see, do you guys see one thing called DQ? Is it an interface?
Yes.
It is extending from queue interface. Now, what is a DQ? The name it's and which from which version it is introduced? Look at here. From Java 1.6 onwards, this DQ has been introduced. Okay. Now, what is a DQ? The full name of the DQ is double-ended queue. That means in this DQ, see, if it is a stack, from where you can do the operation? From only last position, correct?
Yes.
If it is a queue, from where you can do the operations?
Starting.
From the starting position. But if you want to do these two operations together, that is nothing but a DQ. In a DQ, you can delete from starting, you can delete from ending. You can add, you can get the starting element, you can get the ending element. You can add the data using a starting, you can add the data at the end also. See, before 10 also you can add, after 70 also you can add, correct? If I'm adding a data at after 70, that means I'm adding at last position. If I'm adding the data before 10, that is called adding the data before head, correct? So, I mean, like double-ended queue is something which follows the DQ. The full form of a DQ is nothing but double-ended queue, in which you can do the operations called stack operation, queue operation you can do. Now, since DQ is what is a DQ? It's an interface. Can I create an object?
No.
So, do you see there is one class called array DQ?
Yes.
Now, using the array DQ, you can perform, you can create an object of array DQ, and then you can perform the operations. Now, let us see that also. Now, what I will do, I will create, instead of linked blocking queue, let me create array DQ. guys, I'm just using an integer, but instead of integer, can I add an employee object?
Yes.
Yeah. It's up to you. Generics can be anything. Array DQ, done. Now I'm just keeping AD dot add. See here, apart from add method, do you see one method called add first? Add last, correct? So just for time being, just use add method and then add the data. Then we'll come into all the methods. Okay. Now, if you look at here, now this is the array DQ. Now, if I want to get a poll kind of stack kind of a behavior, what method I have to use? AD dot. Do you see one method called poll? See, poll method is there. But apart from that poll method, you see one method called poll first and then poll last, correct? Now let's look at the poll first. See, retrieves and removes the first element of the DQ. On returns null if the DQ is empty. That means, can someone guess what is this functionality? Is it a stack functionality or queue functionality?
Q.
Queue. That means if I want to get a queue kind of a behavior, which method I have to use?
Poll first.
Okay. Now, if you look at here, poll last, what is the definition here?
Last element retrieves and removes last element of the
From the DQ. So that means in stack, you will get a last element, right? So that means the pop method in the stack is equal to the poll last method in the queue, right? Let's do this. Okay, done. Now let us see in this data structure. You tell me if I try to print it AD, done. Now I'm doing AD dot poll last. What is the output of this line?
12.
Does everyone agree with me?
Yes.
Yeah. So guys, Satish is answering. It does not mean that he can only answer. You can also unmute yourself and speak. And if you have any questions, you can please stop me. Okay. No. So because I wanted you guys to be responding, because if I only speak, sometimes you may get sleep also in the
I
morning.
think
itself.
I was not answering. Somebody was answering. So Harish or somebody was answering.
Yeah, fine. Sorry. Yeah, like whoever it is answering.
The default poll method will pull it from the last or first.
I'll come to that later. I'll come to that. We'll see that also. First, we'll see this behavior, and then we'll come to that also. Okay. So now, if I say poll last, it is returning. It will return 12. Okay. Now, if I say again poll last, what it will return?
13.
Yeah, because the 12 is deleted. Now, similarly, poll first.
10.
Poll first means it will delete 10. Correct. Now, if I call again poll first.
20.
Yeah. Now, if I say now I will say peak first. What is the output?
30.
Peak first?
30.
30.
Okay. If I say peak first again?
30.
30, right? Because the peak method will not delete it, correct? Now, if I say peak last?
1.
See, first I will say, when I say peak last, 12 is deleted. Peak last, 13 is deleted. And what is left out? 1. So peak last will give 1. And
1.
again, if I say peak last again?
Same. 1.
1 only, correct? Yeah. So now let us say I want to add. Say I'm writing the output. We will verify this output at the end. Okay. Now, let us say sysout or else AD dot add. So you have one method called add first and add last. See, whenever you are saying that you are, see in this DQ, you are doing the operation from starting, you are doing the operation from last. See, as of now, I have done the operations of deleting and then getting the data at the last. But at the same time, I can also do adding operation, right? So add, if you look at here, add first. See, insert the element at the front of the queue. That means, can I say it is before the head, correct? Or before 0th element? Or if you say 0, then when I say before 0 means it does not go in a negative. That means whatever is that, it will do the right shift operation, correct? See, already I have a data. So now if you look at here, after all this, what is the element is present, guys? Peak first means 30. That means, can I say this is my data structure now? 30, 05, 30, 05, 14, 3, 1, correct? This is my Q, DQ, correct? After performing all these operations, does everyone agrees with me that this is my DQ present?
Yes. Yes.
Now, if I am saying that add first of 15, see currently what is the index is? 0. In 0th position we have 30. So if I say add first means before 30 will be, it will be inserted. But does it mean that I am going into a negative index?
No. Shift
No,
operation.
because
No.
yeah, because in array we do not have a negative, correct? If it is a linked, if the internal data structure is a, see, the same thing can be like this also, like data structure, linked list, correct? See, this is a data structure. It can be linked list, it can be array list. See, 30, 5, 14, 3, 1. Then if I am adding a node 15, can I say before 30 I am adding? And then this was a head earlier. Now I will remove this. This will no longer be head and this is a head, correct? That means add first is nothing but adding a node before the head. If your data structure is linked list, am I right?
Yes.
Now,
Yes.
similarly, add first means I have to, if it is an array, if your data structure is array, then what does it mean? You are going into a negative index? No. You are putting at 0th position, you are adding 15, and what this is getting right shifted, correct? 30 was earlier 0th position. Now it will go to first position, and 5 is in one position. It will go to second position, correct? 14 will go to third position, and 3 will go to fourth position, and 1 will go to fifth position, correct? That means what is happening? Whenever you are adding add first, if it's a data structure is array, then it is doing the right shift operation. If it's a linked list, then you're not doing any shift operation, you're just changing the head. I hope you understand.
Yes.
Yeah. Now let's look at here. Add first. Add first means let us give some number 1, 2, 3. Now let us call add last. And let me give 890. Now let me print sys out AD, and then I will print the data structure after adding the data. Now let's run the program and see the output. See, first let's run, see here, what is the output? It is giving all the data, correct? Now from line number 21, what have we written? 12. Is it 12, correct?
Yes.
Now line number 22.
13.
Yeah, right. Line number 23, 10,
Last
correct?
13. Yes.
Yeah. Line number 24, 20, correct? Line number 25, 30.
30.
Next is also 30, 1, 1. See, 30, 30, 1, 1, correct. Now after that, I am printing the AD. AD is giving you 35, 14, 3, 1, correct? See, this
Yes.
is my data structure, 35, 14, 3, 1, done. Now after that, what I'm doing, I'm adding 1, 2, 3. Where 1, 2, 3 is added? Look at here, 0th position. And then it is getting right shifted, correct? Yes or no?
Yes.
890 is has, see, whenever you use the add last method, it will add it last. Whenever you use add first method, it will add first. Okay. Any questions so far? I'll come to the pop and poll method, but any questions so far?
No.
Yeah, what is the implementation, the library implementation? Is it they are doing with the linked list or?
Yeah, so that we can see. See, it all depends on, see, if you want to implement, you can do anything, okay? But the default implementation, let us look at here. They will be doing maximum array only. See, if you look at here, linked blocking queue, internally in this one, they'll be using a linked list kind of a thing. But in array list, I think they'll be using an array kind of thing. Let's use add first. Yeah, they're
Okay.
using an object array only. So that's the name. If you look at here, linked blocking queue. Internally, they will have something called node structure. Let's see. See, static node
Okay.
item, correct? That means once you know the proper array list internal implementation and proper linked list implementation, can you say studying all the data structures is becoming easy?
Yes.
Yeah, look at here. It is a static inner node only, item, and then node next. Can you say this is the same thing that we have written inner data structure in our custom linked list?
Yes.
Yeah, custom node we have written.
Yeah, custom, but the name that we kept is a custom node. Wantedly, why did I keep? There is no mandatory that you have to keep the node name as a node only. Java creators have used that. It does not mean that we can use it, right? Sometimes we take the things granted, right? But no, you can write your name also in order to tell that I have used the name as a custom node.
So internally it uses the linked list, right? But,
Yes, for linked blocking queue.
Oh, okay.
But if you're
For the
coming
other-
at a array queue, see, it's depends. Say the name itself is linked, right? If you are going
Okay,
for array
okay.
blocking queue, it will use an array. If it is
Okay.
going for
Array-
array DQ, it is using a array kind of a thing, correct? See,
From the name we can identify that. Okay. linked blocking.
yeah. And if you have a confusion, see what it is using internally, it doesn't matter for us as long as we are able to implement it.
No. The point here is when we want to write a customized stuff like that, it is better to have the baseline what is the internal
No,
so that
so now you can implement. See, I have implemented a stack using an array. I have implemented a stack using a linked list, correct?
correct.
Similarly,
Yes.
we are also going to write queue implementation using array, queue implementation using linked list also.
Okay, got it.
So we haven't tried it. I am just explaining all the predefined classes. And then see that means it based on your implementation, you can choose what type you have to store the data. See, queue
Okay,
is a
got it.
passion, like queue is one pattern that you will follow. But whether you are whenever you are using a queue, do you go with a queue of array storing a data or storing a data in a linked list? It all depends on
Okay.
you.
Yeah. The other question which you said you will be answering down the line is like the default add will be first or last, or we can override anything. Either if I want to default by first or last, I can also have the option to specify.
Because see, these are the methods are already overridden, so we cannot
No,
override
I'm
again.
talking about the add method. The add method.
Okay. So in the array DQ add method you are talking?
Array DQ add method.
Okay, let's look at that now. Okay. Now AD dot add. If you look at here, insert the specified element at the end of the queue. So that means what it will follow? Add is similar to the add last. See, you can see that message also, correct? So generally,
Okay.
if it is an array list or in an array list, where are you inserting an element? Whenever you call the element?
Insert the object.
See, for example, first time I am calling the add method in array list. Where the data will go?
In the object of array list. Array.
What index?
In the last index.
Zero. First time it will go 0, correct? Next time if you call, you are going into 1. That means, can I say at the whatever the last index is there you are inserting, correct? Similarly here, add method is similar to add last. By default, if you are using an add method, it is called as a add last also.
Is there any overloaded method in the add that I can reverse the order or something if I want to go with the
See, you have, overloaded method in the sense?
only add and add all? There is nothing like a comparator where we pass the reversing the order, right?
That is
We
nothing
pass
but a priority queue.
Yeah, okay.
So there is a class called priority queue in Java. See here, whenever I'm printing, see here, can I say whenever you are printing in 20, now how do I know whether it's a first in, first out? If I am calling the poll last method and it is giving me 12 means, can I say that 12 is last added element? Yes or no?
Yeah.
If I say poll first and if I'm giving 20, that means 20 is say here, 10 is firstly added. Now let's do the same example with a priority queue. Since you have brought up a question, let me show you that. Let's copy this.
We
And
are seeing the third queue now. Wait.
what?
No, we are seeing the third type of queue. First is flocking and then DQ
Yeah.
and then.
There is no CVRT level, nothing like that, but I'm just explaining. Which, see, first if I am explaining the DQ directly without a queue, does it make sense? No, correct? So I'm following order, like, so that you can understand. So now there is a separate class called priority queue. Now there is a different importance for the priority queue. Let's discuss that. Since you brought up a question, I'm explaining again.
Also,
Like
one thing, you always have the class and class in the left and right in the generics, right? But it is recommended to have an interface equal to the new implementation, right?
Yes.
Default is which one should I use? The left side? I mean, for every queue, it should be a
Yes.
default.
Generally, you have to use a queue like this.
Queue only, right? Okay.
Yeah.
Okay. That's fine.
Yeah. But so some people see when someone might have not attended that class where I have explained what is the advantage of using a parent reference and creating a child object and referring it to a parent. They might not have attended that class.
Yeah. Because you have followed the pattern in the hash set and hash map or the list and thing array list. But here I'm seeing you are using the same class name, so I had.
Yeah, fine. Now, if I say, guys, what can someone give me what is the output? If I say ad1.poll, okay, so it's a simple, it's not a DQ. So if I say poll, what is the output? Can someone tell me?
10.
Okay. So now that is wrong. It will give the output as 1. Why it will give? Now the question is, now see, when I say, how do I know the queue behavior? First of all, by looking at the line, by printing the object, or by looking at the output of a poll method.
Printing the object, we can see.
If you print an object, what inside a toString method? See, you're printing an object, it is going into the toString method, correct?
Yes.
In toString method, what is your objective? Are you following the insertion order, or whatever the data structure internally they are using, you are iterating over the data structure and then printing the data? Are you guarantee any order in the toString? In the toString,
No.
the purpose of toString method is to print the contents of an object, correct?
Correct.
It does not mean that it should follow the same order or insertion order or ascending order or descending order. It doesn't matter. But till now, whatever you have seen, it is same, correct? If you are printing array list, it is same. If you are printing a vector, it is same. But if you are printing a hash map, is it giving you the order? In hash map, it's not ordered, correct? That means if you print the hash map object, it will give you different orders, correct?
Yes.
Yeah. Now that means, can I rely on this line number 22 to see what is the data structure it is following, whether it's following an insertion order, whether it's following a ascending order, descending order? Can I rely on printing an object or toString method? That is not the right approach, because see, if I'm relying, then poll method is giving a different output. What does it mean? See, poll method is, see here, what is the functionality of a poll method?
It returns the first element in the, head 0th position in the queue.
And it will remove it, correct?
Correct. Yes.
That means, can I say if the poll method is returning 1, though you have added here, can I say this is the first element in the queue? Yes or no? I'll come to that. But what is my point I am trying to tell you is, if you want to see the behavior of a stacker queue, how can you do? You should not look at the object printing. You should look at the output of a poll method or pop method and then understand the behavior, correct?
Yes.
So till now, whether you are following array blocking queue, linked blocking queue, array DQ, stack, vector, all these classes are whatever the data, whatever the object you are printing and whatever the pop you are doing, it is working. That's fine. But priority queue is something different than other queues. Why it is? Because priority queue internally follows natural sorting order. Natural sorting order. So can someone tell me in the collection.sort, if I don't mention anything, what it is called?
Comparable.
So that means whatever the generics that you are passing, it will go and check whether the generics is implementing a comparable interface, and it will call the compare to method, correct?
Correct. Yes.
Now, similarly, here in line number 12, what am I doing? I'm creating an object to a priority queue. Now let's go to the constructor. Here in this constructor, what is the meaning of line number 129?
You're calling constructor.
There, see, from this one, this is nothing but a constructor, and you are passing two parameters, correct? Yes. Now, what is the second parameter? Null. So that means, can I say I'll come to priority queue one more, this constructor, correct? See, these are one parameter, these are second parameter. Now you look at here. What is the thing they are having internally? Comparator. You are passing the comparator as null. If you are passing the comparator as null, by default, what is the data that you added in this one? Integer. Can I say it will go to the integer class, comparable, and then compare to method, correct?
Yes.
Yeah. Now, what is the logic of a compare to method?
Default match.
Default, what does it mean? Ascending or descending?
Yes. Ascending.
Ascending, correct? So that means though you are adding the data, so every time it is shuffling the data, correct? See, whenever you add the data, it will call, see, since you are not passing any comparator, but this generics is having a comparable interface, right? So it will go to the comparable interface, and it will see, though you are giving some different order, internally priority queue follows natural sorting order if you're not providing a comparator. So out of these all the elements, you tell me what is the natural sorting order means?
Ascending order.
What is that? You tell me the data now.
1,
Yeah.
3, 5.
Next.
12, 13, 14.
10,
I mean 10. We missed 10.
Yeah.
10.
5, 10, 12.
13, 14. 20, 30.
Okay. Now that, can I say that means though you are giving the data whatever you want, okay? So that means internally how the priority queue is storing, it is not storing the data whatever you are giving. And whenever you're printing the data, it can give you any order. Whenever you're printing an object, what does it mean? You're printing a contents of the data structure. It does not mean that you are following the same order. Sometimes it may be true, but sometimes it may be false, right? But how the priority queue is storing internally, it is storing in this way. Now, in order to prove this, it is storing in this way. If I call the poll method once, it is giving 1. That means though you are adding 1 here, what internally it is doing, every time it is calling the compare method, and then based on the data that you have passed, it is storing in the natural sorting order. Now, if I call pop again.
Can you please run this program? I want to see the output. It is printing 10, 20, 30, like that.
I'll run it. I'll run it. Don't worry, I'll run it. Let's see. Instead of depending on the compiler or Eclipse, just write the output from our end, and then we'll make sure that whether it's working or not. Okay, just give more 5 more minutes. Okay. Now, if I do the poll method again, what is the output?
3.
Okay, that means it will look at the data that this like this, correct? Not the one it is storing, right? Now, if I say 5, next output is 5. Now, if I say peak, what is the output?
10.
Yeah, because 135 is deleted. Now, let us say peak again. What is the output?
Same 10.
10. Now let's run the program, or let's debug the program instead of running. Debug as Java application. See, it is calling the compare. So let's remove the compare from here, time being. Let's put the breakpoint. See, if you look at here, guys, see here, whenever I'm adding a data, sorry, let me debug the code again. See, I created a constructor. So now whenever I from line number add, okay, now I'm just adding the data. Okay. Now, second time, whenever, see, first time, the compare method, even if you are calling only one element, there is no point of comparing. Now, whenever you are adding a second time, now let's go to the integer class. Let's put a breakpoint in the compare to method and see whether it is calling here or not. See here. Is it calling the integer class compare to?
Yes.
Now, but
Yeah.
did I pass anything here?
No.
Because the reason is whenever you are creating a constructor, what are they passing? They are initializing the comparator to null. That means you are not providing any external comparator. If you're not providing any external comparator, this priority will go and check in the integer wrapper class. Are you implementing comparable interface? Yes. Then it will go to the compare to method. If you're passing a generic called employee or department, which does not implement comparator nor comparable, then it will throw the compilation error. We will see that later. Okay. Now let's see, look at here. Every time, whenever you add a data, whenever you add an element, this comparator will be compare to method will be called. Look at here. See, from add method, again, it will call. See, is it calling? See, again, a compare to method, again, compare to method. That means every time you are adding a data, what it's doing? It is going to the compare to method, and then it is sorting the data in a form in such that it is a natural sorting order. Now let's come to the line number. Let's execute F8. See, I'm adding, whenever you are adding, it is calling. See, now if I'm looking at the data, see, is it a insertion order? The one who asked the question, is it following insertion order, ascending order, or descending order?
But it's not insertion order, but can we know in what order it prints? Like
that is what whenever you're printing a data, you're writing a toString method. ToString method implementation is you have to print the contents of a data structure. It does not mean that you have to follow order, correct? But till now, whatever the data structure you have studied or you have looked at, it is following the same insertion order. But here, internally, it is using a comparator. So that's where it can give you any order. See, whenever you are implementing a toString method, there is no condition that you have to follow this order only. Like the purpose of the toString method is to display the contents only. Okay.
So we can't just
but the integer is over
the toString. I mean,
yes, that is what I wanted to say. If it is a specifically priority queue, you cannot judge by looking at the data. You cannot judge by looking at the toString. You have to understand that if the priority queue, am I passing any comparator?
No.
If I'm passing a comparator, I have to go and look at my comparator logic. According to the comparator logic, the data will be stored internally. If I'm not passing, and I have to look at the generics. In this generics, these are the wrapper classes. So by default, all the wrapper classes will follow natural sorting order. If I'm passing an employee, then I have to go and look at my comparable interface or comparator in that employee class, correct? So if I run further, look at here the output. So, sorry, let me remove this. Let's put a breakpoint here. See, what is the output? 1. Did we write 1?
Yes.
Now, what is the output again? 3, 5, 10, 10. That means, can I say if it is storing like this, then only the output will be possible like this, correct?
Yes.
Yeah. So that is the beauty of a priority queue. Priority queue internally follows the comparator.
One question, sir. If I see, you said generics has one comparator. That is what now it has been used here because we didn't pass the priority queue constructor any other class which is going to override that. So the order goes based on how the constructor is called on the priority queue. Then, if not, it will take the generic the implementation of a comparator, right?
Yeah.
That's how it is.
Yes. Now, so look at here. I just created a class called department. Is it implementing a comparator?
No.
Is it implementing a comparable?
No.
Now let's write department here.
Exception.
Now, okay. Now, if I add the data, yeah, it will not throw the exception because it will go, see, the object class is parent class, right?
Yes, I mean, it will go to object class.
Yeah. But so here, here, it's a wrapper class, you know where to go. But if I want to sort department, so there is no. So in the, see, if I here, did I pass any external comparator here?
No.
No.
So then it will go to the department class. That is the department implements, like if I have to implement a comparable or comparator, okay? Comparator or comparable, anything. And whatever the logic that you write here, it will go there. Or else, now let us look at here. Now here, I don't want to go, see, if there is one way I can mention the external comparator also. Now what is that is, let's copy. Or else what I will do here, let's create a class. Collections dot reverse order. See, what does the, see, in the collection, there is a method called reverse order. What it is giving you?
Compare
What
it.
is a comparator, correct? Now, which constructor I am calling? Priority queue, which takes a comparator, correct?
Yes.
Now, what is the order I have passed? Reverse order. Now, if I call the poll method first, what is the output I'll get? I'll get 30, correct? So that means the data, how it is now? See, since I have passed the external comparator, it will not go to the integer class compare to method.
Okay.
And it will return 30 now. Let's quickly debug. So I'm running out of time. Let's do quickly and then we'll follow tomorrow. So that means it's all depends on what you are passing. See, if I suppose, see, is it coming 30? After 30, what is the last element? 20, correct? So that means whether, see, how the priority queue decides the order based on the comparator that you passed. If you do not pass the comparator, it will go to the your generics. Is your generics is implementing any comparable or comparator, then it follow that order, correct?
Yes.
Yeah, it's clear now. But I do have a question on the department. You didn't write the comparator, but by what order it will? So
It's
maybe
for
we can
department.
talk
What is a for department? What is a parent object class? In object class might be there. Yeah, it will follow that order.
Okay, object class as a comparator. Huh? Okay.
Yeah, it will be somewhere. It will be implemented, but I'll tell you that tomorrow. Okay.
Okay, tomorrow we'll discuss that.
Yeah.
Thank you.
Yeah. And tomorrow we are also going to see the queue implementation using a array. I mean array and then queue implementation using a linked list. But you already know how to implement the poll method means remove of 0. Peak method in the queue means giving the first element. Can you guys write a program? Queue implementation using an array, queue implementation using a linked list. We already know how to implement array list using an array, linked list also. Custom linked list, custom array list we know. In those classes, I just need to write poll method is nothing but remove of 0. Peak method is nothing but returning the 0th element. Similarly, in the linked list, poll method means nothing but removing the head element. And peak method is nothing but returning the head element, head.data. So can you guys try?
Yes.
Yes.
Yeah. Please try, guys. Anyways, I'll be writing the code, but if you try it, so there is important, like it will build up your confidence. Okay. Please write. I'll put that homework in the chat also. Yeah. Yeah. Thank you, guys. Sorry for the delay of 10 minutes. Yeah. We'll see you tomorrow. Thank you.
Thanks.